Hello everyone, my name is Hemu and today's we are going to discuss how to do the redistribution between OSPF protocol and BGP protocol in this particular lab environment. And guys, it's like a double ISP kind of case. Okay. So if you will see here in this lab, I have my Palo Alto Firewall. This Palo Alto Firewall have a two interface Ethernet 1x1 and 1x2. These two interfaces is a part of your outside zone. And we have a ISP from Airtel and we have a ISP from Tata. These are the two internet connection which I am having. So guys, I will configure BGP between this Palo Alto firewall and these ISP routers. And also I will configure the BGP here between these ISP routers and your internet router. And I do have one DC server router here, which have a connectivity with my home Wi-Fi. So I can able to reach till the actual internet from here. So in this segment, I am going to basically configure the this BGP protocol, and I will use here in Palo Alto, I will use BGP 65001 as our autonomous system number, and here I will use BGP 65002 autonomous system number or AS number. Apart from that, I do have a DMZ environment, inside environment, and DMZ2 environment. And in this environment, I'm going to configure the OSPF protocol. Once we will do the configuration, we will try to see how we can do the redistribution and other things. Okay, so first we will build this lab from scratch. So now let me just start. And guys, this is just a continuation lecture of your routing series in Palo Alto Firewall. And today we are here into the how to perform route distribution between BGP and OSPF protocol. So that's the agenda of this particular session. So without wasting time, now let me just take the access of my devices. So I'll just open all these devices. And I'll just start my configuration starting from inside R2 router. Let me just type no everywhere. Now I have access for all of my devices. Let me just start with this R2 router. I'll go here, conft host name. I'll give the name like inside R2. I'll configure these two interfaces, F0y0 and F0y1. Interface F0y0. IP address is 10.1.0.1, 255.255.255.0. No shutdown. Exit. Then we have an interface 0y1. F0y1. IP address is 10.1.1.1, 255.255.255.0. No shutdown. Exit. Now here I will also configure so this is the configuration, guys. Now I will just configure the telnet, SHS and HTTP services on this router. So I'll just copy this configuration. This will enable the telnet. This will enable the SHS, and I will add one username, and this will enable the HTTP services on this particular device. I'll go here, go and copy. Just wait here. So this config has been done on this router. Now this is the configuration which I need to do on my inside R3 router. On this router, I will configure the IP address on this interface, this interface, this interface. I will create some loopback interfaces here. So config is pretty straightforward, guys. I'll go here. I'll type conft hostname inside R3 interface F0 by 0. No shutdown. IP address is 10.1.1.2 255 255.255.0. Then we have another interface at interface F0 by 1. IP address is 10.1.10.2. No shutdown. Then we have another interface which is F1 by 0. And IP address is 10.1.20.2. No shutdown. Exit. Now I will add these loopback interfaces. So what I can do, I'll just copy that loopback related configuration. Like this is the this is how we have to make the configuration here. And these are the loopback interface configuration. Let me just copy and paste. And after that, just copy this because I have already created that script actually. So it will save hours sometime. Now go here and just configure the telnet, SHS and HTTP. It's just a normal IP configuration, guys. Okay. Now we have a DMZ 1R4 router. This is the configuration. This configuration take this device into enable mode, then config mode, and configure the host name. So this is the one thing which you need to do. Now we have to configure F0 by 0 interface. This one, which is connecting this router with the firewall. And we have a few loopback interface. So it will create few loopback interface and it will also enable the telnet, SHS and HTTP services on this device. I'm just doing the copy and paste because this config is very easy. It's not a routing, nothing. It's just a IP configuration in your device. So now in DMZR4, we have to do the same thing on this device. We have to configure IP address on F0 by 0 interface. Then we have to create the loopback interfaces and we have to enable the telnet and other things, right? Telnet, SSHT. So I will just copy this entire configuration to just save some time because this is the same config which we did in our previous labs as well. Okay, so I'm not doing this thing like in every lab from scratch. Let me just use my previous created scripts actually. Now we have just successfully completed the configuration on your inside devices and DMZ devices, right? Now what, before going into this Airtel Tata ISP configuration, let me just start configure my Palo Alto, and after that we will enable the OSPF protocol here and we will just validate the connectivity internal, and after that we just move further. I'll go here into the Palo Alto. This device get the IP address from DHCP. So let me go here. Increase the size. Username is admin. Password is also admin. Wait here. Old password admin. New password is admin at 123. Admin at 123. Wait here. Configure. Set device config. System. Hostname. Palo Alto Firewall. 1. Set device config system. Type static. It will enable the static IP configuration. Set device config. System. IP address, configure the IP address on this device, which is 192.168.137.10. Net mask 255.255.255.0. Default gateway 192.168.137.2. DNS servers. Primary DNS server is 8.8.8.8. Secondary DNS server is 4.2.2.2. You can define the NTP server config as well if you want, because just in single line you can able to do everything. Just click this. Now set device config, system, time zone, Asia, Kolkata. I will change the time zone. Set device config, system, NTP servers, primary NTP server. So primary NTP server is 0.n.pool.ntp.org. But let me just double check. India public NTP server. This is the one. 0.n.pool.ntp.org. 0.n.pool.ntp.org. Yes, that's correct. Invalid syntax. NTP server address 0.n.pool.ntp.org. Authentication type is none. Enter. Then set device config, system, NTP, secondary NTP server, NT server address, which is 1.n.pool.ntp.org. Authentication is none. And after that, just do the commit. Now we will wait for this commit to complete. Once this commit will complete, we will start rest of the configuration. This is the configuration which we just now did. We have not added this line, but it's manageable, right? If you want, you can add this line as well. Now I will start the configuration of my other things like virtual network, interfaces, everything. Let's wait here. %98. Now if I'll go here, If I'll type https colon 192.168.137.10, I will get the access. Meanwhile, you can open the CLI from here as well for this device. Go here, open your Palo Alto 10. It's done. Now you can close from here, not needed. Now we will manage everything through this CLI. You can get the GUI access. You can log in from here. Now we will get the final access from here as well. So let's wait here for some more time. Now let's just start the configuration on this device with regards to the interfaces. So first of all, you will see we have to delete this default route. So I'll show you, you can delete directly from here, but I'll show you how you can do that with the CLI. We have to create the zones and we have to do the interface configuration, right? So now let me just start that config as well. So we will see everything through the CLI. I'll go here, I'll run this command. Set CLI config output format in set. So I can able to see all the config on set format. I'll just type delete network virtual router default. I will delete this default router. Now you will see this router is not available. We don't have anything here. Okay. Now what we will do now, we will first create one virtual router. Set network virtual router VR0. I have created this virtual router. Now you can see, you will able to see new virtual router has been created here, VR0, right? Now I'll start the configuration on my interfaces. So I'll go here, and if you will see my lab, Ethernet 1 by 1, I will first configure this interface Ethernet 1 by 1. So how I will do that? I'll just run this command set network interface Ethernet 1/1. Then you have to define the comment. This is my outside interface towards ISP01. So I have defined this comment. Wait a minute. Ethernet, then Ethernet 1 by 1 comment outside ISP01. This is the first thing which I will do here. Now set network interface Ethernet 1 by 2. This is my layer 3 interface. So I will define this interface is my layer 3 interface. And I have to define NDP proxy enabled. No. Now see, I have changed this interface type here. If you will go here, you are able to see this type has been changed. You will to see comment. Now we will now I'll show you how we have, because you know in last you have to define the interface management profile. So we have to create that profile and we have to configure the virtual router, security gateway, virtual router, and this security zone we will configure later. Then IP address we will configure. Okay. So now what you have to do now, I'll go here, I'll run this concept network interface Ethernet 1 by 1 layer 3 IP address is your 151 dot, let me just see, 151.7.z 250, right? So I'll just configure that IP address. 151.7.250/24. This is the next thing which I need to do. Now I will create one interface management profile, set network profiles, interface management profile. I'll give the name to this profile, which is ping, and I just select here ping, enable yes, hit enter. Now set network interface Ethernet 1x1 layer 3 interface management profile, which is ping. Now set network interface Ethernet 1x1. Now what we have to change the link state. Link state is up. This is the configuration which you need to do into your Ethernet 1x1 interface. Now if you will go here, if you will refresh, you will be able to see the settings. You can see here, I've configured the interface, comment, interface type, virtual router and security zone we will add later. Then IP address, and I have just make this interface up and I have called the interface management profile. Now you have to do one thing. Now you can run here one command, set zone outside network layer 3 Ethernet 1x1. Now you can see I have configured the zone as well on this interface. You can see security zone is outside now. Let me just configure the virtual router as well. Right now it's none. This virtual router is none. Let me just add the virtual router. Set network virtual router VR0. You have all these things. Just select your interface Ethernet 1x1. Now you can see I have did all the interface related configuration with the help of CLI, right? We have the type, interface management profile, link state, IP address, virtual router, security zone, and comment. Now in similar way, we have to go do the for other interface. So what I will do, I'll run this command. So network interface Ethernet 1x1. Now what I will do, I'll just copy the things till here. This line I'll just type it out ISP2 Ethernet 1x2. Because Ethernet 1x2 is a part of my ISP2, I'll just configure this part. Then I'll go here. I'll copy this value and I'll just change 1x2. I'll go here, configure the IP address. Go here. And I will just put here 160. I'll go here. So this is similar for both the interfaces. One by two. Now this is the config which you need to do. And after that, what you have to do, you have to configure virtual router Ethernet 1x2 means on the same virtual router, and I have to configure now zone. Set zone outside network layer 3 interface Ethernet 1x2. Now you can go here and you can able to see I did the configuration on my next interface as well. Looks like there is this IP address I have configured wrongly here. So let me just check. Yeah, so you can see this. This is the one which we have configured wrongly, right? So what you can do, instead of set, you can just use here delete. It will delete. And you have to just change this Ethernet 1 by 2 here. You can go, you can just validate the things. Now everything is fine here. We have configured these two interfaces towards outside. Now let me start configure Ethernet 1 by 3, 1 by 4, and 1 by 5. I'll go here, run this command. So network interface Ethernet 1 by 1. I can just take the reference of this Ethernet 1 by 1 interface. Now let me just do the configuration for my interface, which is Ethernet 1 by 3 towards DMZ1. I'll go here, copy this, copy the entire thing here. I'll open the notepad. And instead of 3, 1, you can just make it 3 everywhere. And here you can just change. This is my DMZ1. An IP address in that series is 10.2.0.250. This is the one. 10.2.0.250, right? Everything is fine. Just you can copy and go here and paste. Apart from that, set network virtual router VR0, then interface Ethernet 1 by 3, set zone DMZ01, network layer 3 Ethernet 1 by 3. So you just copy this as well. Let me put here. And let me copy this as well. Right? We did the configuration of that interface as well, and you can validate. So you can able to control everything with the CLI if you know how to basically do the things. Now let's configure Ethernet 1 by 4. Ten dot zero. Sorry. So this is DMZ2 10.0.0.250. This is my DMZ2. Copy, go and just paste. Now you can see we have configured this interface as well, right? Now let's do the configuration of Ethernet 1 by 5. 1 by 5 is also pretty easy. You can go here. You can just modify these values. 1 by 5. Inside 10.1.0.250. Inside, go and just paste. You can go ahead and just do the commit. Now if you will go here You can able to see all the interfaces I have configured with the help of CLI in your Palo Alto firewall. Now, meanwhile, this commit is going on. Let me just start the OSPF configuration in my LAN environment. So OSPF configuration is also pretty straightforward, guys. We don't need to do much thing. So what I have to do, I'll go here. I will start with inside R2 router. Conft. So here I will go router OSPF 100 network. So these are the network I'm having 10.1.0.0. Then we have to define the wildcard mask 0.0.0.255 and area 0. I will just configure everything on area 0. Then 10.1.10.1.0. Then we have a 10.1.1.0. Do right, ma'am. Just save the configuration. We have enabled the OSPF here on this router. Now let me enable OSPF on my inside R3 router. Enable conft router OSPF 100 network 10.1.1.0.0.0.255 area 0. Then we have a 10. We have a 11. Sorry, it's 20. 10, 20. Then we have a 10.1.2.0. We have a 3.0. We have a 4.0. We have a 5.0, 6 and 7. 6.0 and 7.0. Exit, because these are the loopback interfaces. So what I will just change the network type. So I will run this interface range loopback 1 till 6 IP OSPF network point to point. Now that's how, guys, we have to configure the OSPF protocol on my inside R3 router. Now you can go here and just run write mem command. You can go here. So IP OSPF neighbor, we have the neighborship. So IP route OSPF, and you can see we have the routes for all the loopback and 10 series and 20 series. We have a 10 series, 20 series, and all loopback starting from 2, 3, 4, 5, and 6. Even though we can able to ping from here as well, like 10.1.7.1 ping is happening, right? Everything is fine. Now go ahead, just configure the OSPF in your DMZ1 router. Go here, conft router OSPF 10. Let me just use the same OSPF number, which is 100, not 10, because this doesn't matter, but let me just go with 100. It will make some symmetry actually. 10.2.0.0. And here what I can do, I can maybe just configure one subnet, like I can use the summary address here. I will use 10.2.0.0. So I'm having a subnet from 0 till 7, which means it has around 8 subnets. So, and this subnet is a part of your 248 series, like 255, 255, 255. Sorry, 255, 255, 248.0. Like on this, all they come. So 0.0.7.255 and area 0. I think this will take care of everything. It will cover all the subnets. Exit, interface range, loopback 1 till 7, IP OSPF network, point to point. Do right, ma'am. Go and do the same configuration here as well. Router OSPF 100, network 10.3.0.0, 0.0.7.255, area 0. Exit, interface range, loopback 1 till 6, IP OSPF network, point to point. Right, ma'am. Now what I will enable the OSPF configuration on my Palo Alto Firewall. So I'll go here. You can see after when last time we did the commit, now you can see all your interfaces in up state, right? Which is a good sign. Now what I can do, we have a zone as well. Everything we have created from the CLI. We have a virtual router. Now you can go here and I will start my OSPF configuration. We can do the OSPF configuration as well with the help of CLI, but that config become very complex actually. So that's why to avoid the complexity, I'm going with that. Enable. I am deselecting this option. So what I will do, because I will redistribute the default route from this router. It will reach here, then reach here, then it will reach to firewall. In BGP and from BGP, I will redistribute into OSPF. And OSPF is only accept that route if we have selected that option. Or let me just go with the default for now. Router ID is 0.0.0.250. Area. Area is 0. Interfaces. Define all your interfaces. 1 by 3, 1 by 4, 1 by 5. I'll go with default here. Ethernet 1 by 4. Ethernet 1 by 5. Range. If you want, you can define the range, but I don't need it because we have already enabled the OSPF at the interface level, so it will take care of everything. We don't need to do anything here. Not needed. Click on OK. Let's go here and let's do the commit now. Let's wait for this commit to complete. And meanwhile, guys, in your production environment, if you want to see the details, you can run this on debug. Data plane. Debug routing. You have to enable the debugging in your routing. You can define like we have a global interface monitor, all these things. So what I have to enable that global on at the debug level. Tail follow yes, mp log route d.log. Here you will see the live logs. You will get some success messages here. Commit is completed and sometime you will see the OSPF neighbors if on these devices. So IP OSPF neighbor. Now there is a neighborship between your Palo Alto firewall and your routers. This is the information. These are the messages they are exchanging. I'll disable the debugging at info level only. I'll go here. So routing route. Run this command. You can able to see all the routes for 10.1 series, 10.2 series, right? Even though you can also filter with that. Type OSPF. These are the routes which I have received from the OSPF. So routing protocol OSPF. What you want to see? You want to see the area details, you can run and it will give you the area details. OSPF. If you want to see the summary, you can able to get the summary detail. This is the summarization. These are the dynamic neighbors. Now, what we have, if you want a neighbors, you want to see the neighbor details, you can run this command, you will get the neighbors details. If you want to see the database with regards to LSA, you can run this command, you will get the LSA details. If you run this command dump lsdb, it will give you the detailed view of your LSAs, your OSPF LSAs basically. Interface, it will give you the interface detail where we have enabled the OSPF, right? So these are the some commands in your Palo Alto firewall which we generally use. Okay, so now if I'll go here into inside DMZ R4 router, if I'll go here, if I run this console IP route, you can see I have the routes for all these CDs, right? Which means everything is fine. Now I'll go here. I'll just add one security policy which will allow all the traffic. I can just test the telnet and other things. I'll give the name here like allow all. In production, you will not have a allow all, but here I'm going because it's just my lab. Let's do the commit now. And in our topology, you can see we have these two machines. Let me just open these two PCs as well. These are the Windows machine. Let me try to increase the size a little bit. We have test PC1 where I have to configure some IP. I have this machine as well. Let me increase the size of it. Let me just do the config. I'll go into the CLI and just type here ncpa.cpl because I need to configure the static IP here. Ten dot 1.10.100 255 then we have a 10.1.10.1. Let me go inside R3. Let me just see. So IP interface brief. I'm using the 10.1.10.2, right? So I have to just put here 10.2, then 8.8.8.8, and 4.2.2.2. Click on OK. Click on OK. Click on this. Now you can go here and just try to ping. 10.2.7.1. See, ping is happening. Even though you can go here, you can type 10.2.5 6.1, take the SHS, you will get the SHS as well of your device. Because you see, I got the accept DMZR, means I have the end-to-end connectivity. Now we can go here. Let me just test from this machine as well. CMD ncpa.cpl. So OSPF config is, guys, pretty straightforward in your Palo Alto. Now you can type here 10.1.20.100. It's 20, and then we have 100, 255, 255, 255.0, 10.1.20.2, 8.8.8.8, 4.2.2.2. Click on OK, click on OK. Just try to ping 10. Click on yes. 10.3.6.1. See, ping is happening. I have the connectivity. Even though I can just take the SHS like 10.3.2.1, and you will get the access of my DMZR2 router. DMZ2 router. Cisco and Cisco. You can see I got the access of DMZ2 R5 router. Means I have the end-to-end connectivity on my LAN area and on my DMZ area. Now let me just start the configuration towards the ISP, Internet Service Provider area. So guys, this ISP related configuration, I will start from this particular device, which is Airtel ISP. Go here. Let me just go to the config. Conft host name ISP01 Airtel. Interface F0Y0. IP address is 150.1.7.1, 255, 255, 255.0. No shutdown. 0x1. 170. No shutdown. Apart from that, now what I will do, I'll just try to enable the, let me just go on top a little bit. Just IP configuration, right? So we have did the IP address configuration on these interfaces. Now I have to enable the telnet. So for that, I'll just do the copy and paste because I will not waste my time. Now I'll go here and I'll just do the Tata router configuration, Tata ISP, and the config is exactly similar. Interface IP address, then we have to enable telnet. So I'll just copy from here till here. This is the config. Just it will just configure the IP address on this particular router as well. So let's wait here. It will configure a host name, IP address on both the interfaces, enable telnet, enable SHS, and enable your HTTP services. Now we have a internet router. In this internet router, you can see I have to configure these three interfaces, F0Y0, F0Y1, and F1Y0. And I have to configure these loopback interfaces, just a normal IP configuration. So I'll just take the help of copy and paste. I'll just copy from here. Just a normal IP configuration, guys. Till here. enable conf t, and you can just paste. Now we have a DC router. So in DC router, you will see I have this interface F0Y0, which I have to configure, and I have to configure the loopback interface, and I have to configure F0Y1, which have a connectivity with my home Wi-Fi. So what I will just take the help of this, it will configure the IP address on your F0Y0 interface of that router, which is this one, F0Y0, and it will create some loopback interface, and it will enable telnet, SHS, and IP. And the remaining thing towards the Wi-Fi router, I will do that manually. Go here to this DC router, do it. Now you can go here. Now interface F0Y1, what you have to do, you have to run this kind of IP address from DHCP. Exit, add one default route, IP route 0.0.0.0, 192.168.29.1, because this is the series from where I'm getting the IP address on my from my DHCP or from my home router. Okay, so I'm just configuring this series IP address. Do so IP interface brief. Forget to do one more thing here. In this interface, I have to run no shutdown command. Right, ma'am. So IP interface brief. You will see the IP address in some time. Now you can see I got the IP address from my home Wi-Fi from the DHCP range, which is this one. Do so run section interface F0Y1. Wait here. This is the configuration which we need to do on that interface. So let me add this as well here. No shutdown. Exit. IP route 0.0.0.0.0 192.168.29.1. Maybe this range, this IP you have to change something else in your case. Let me just save it. Now, if I run this do ping 8.8.8.8, ping will work. See, ping is working to the internet. Now, if these peoples, they wants to also ping, what I have to configure one net here. So IP like interface F0Y1 IP net outside. Is enabling the net engine. So let's wait here. Now interface F0Y0 IP net inside. IP net inside. Then interface range loopback 1 till 7. IP net inside. Exit out. Access list 10. Permit any. IP net inside source list 10. Source list 10, press the question mark. We have an interface and I want to configure the PAT. I want to enable the PAT on the interface, which is F0Y1 overload. Do right, ma'am. Now, whatever host I'm having here, they can also able to restill the internet. Now, guys, we did the configuration here as well. Even though from this DC, if I can just do the ping too, so I think ping will not work right now because I have to enable the routing as well. Okay, now let me just do the rest of the routing related configuration on these devices, like which is your BGP configuration and other things. And how we will do that, I will just do one by one. And that particular configuration I will start doing from my Airtel router, which is this one. So what you have to do on this router, you have to run this command router. Here we have to configure BGP 6500 towards this and 65001 towards this. This is the yes, right here I have to configure 65500 on my BGP router. I have to on my Palo Alto I have to configure 65001. Here I will configure 65002. So router BGP 65002. This is the autonomous system number. Then I will define network 150.1.7.0 mask 255.255.255.0. Then I have another network which is 170. Now I have to define the neighbor details. Neighbor is 151.7.250. Remote AS is 65001. This is the remote AS right here. Then we have another neighbor which is 171.7.2. Remote AS is 65002. Means these devices, they are part of same AS number. Go here, run this command, do right, ma'am. Now do the same configuration in your Tata router. Router BGP 65002 network. We have 160 series and we have a 180 series. 161.7.0 mask is 255.255.255.0. Then we have a 180 series and we have a neighbor 161.7.250. Remote AS is 65001. Then we have another neighbor where we have a 180.1.7.2 and remote AS is 65002. Do right, ma'am. This is the config we have to do on this. Now we have to go inside the internet router, most critical device, where we have to do rest of the configuration. Now in this internet router, what we have to do, we have to run this command router BGP 65002. Now we have to define all your networks 170, 180, 190 and all these networks as well. Network 170 1.7.0 and mask is 255.255.255.0. Then we have 180 170 180. Then we have 190 series. In 190 we have 190 1.7.0 and here we have 190 1.1.0 1.00, right? Just change here 190 1.00. Then we have a 190 1.1.0. Then we have 190 1.1.2.0 3.0 4.0 5.0 and 6.0. 5, 6.0. Do so run section BGP. This is the BGP configuration which I did so far. Right, I have just defined the networks, all my networks. Now what I have to define now, I have to define the neighbor details. Neighbor 191.7.2. Then we have a remote AS neighbor, then remote AS, which is 65002. Then we have a neighbor 171.7.1. Remote AS is 65002. Then we have a 181, 181.7.1, and this one. Do so BGP neighbor. We have the neighbor SIF here. So IP route. Right, ma'am. So IP route. So BGP. These are the routes which I have received from BGP. 170, 180, 1 and 190 series, right? They are directly connected here only. But I'm not able to see this 150 series and 160 series. Why I'm not able to see? So I'll go here. Do so run section BGP. Okay, we have all the details. Now you can see I have received 150 and 160. So it will take some time. Do so IP route. Now you will see these two routes from BGP 160 and 150 because these 190 series here only, right? Now I'll go here in my DC router and I'll just do the same thing. Enable the BGP router BGP 65002. Then we have to define all the networks. Networks is 190.1.7.0. Mask is 255.255.255.0. Then I have to define my that series like 192 network 110.1.1.0.0. Sorry. So now we have a 110.1.1.0, 1.2.0, 1.3.0, 1.4.0, and 5, then 6. And here I will not configure anything actually. Exit. Do. Right, ma'am. And so IP BGP neighbor. We don't have any neighbor save. So run section BGP. We have just defined the network. We have not defined anything with regards to the neighbor detail. Neighbor 170, sorry, it's 191.7.1 remote ASS 65002. That's right, ma'am. Save the config. So IP BGP neighbor save. Now we have the neighbor save here. Let me increase the size a little bit. We have the neighbor save, right? Which is an established state because BGP use TCP in backend. So your state will go in established here. Now, so IP route. Check the routes here. Now here you can see I have the route on 170, 190, and this 1.10.cd, right? Here I'm not able to get these routes, this one and this one. So guys, what I have to do, because you know, I have to make this router as a route reflector. Then only it will basically advertise the routes which it has received here. It will reflect here. And if he is receiving anything from these routers, it will reflect on this particular device only when I will make this as a route reflector. So I'll go here and I'll just go on my internet router. Let me just do that config. Conft router BGP 655002, then neighbor 191.7.2 route reflector client. Then we have other neighbors like this one 170.1, this Airtel ISP and Tata ISP router 170 and 180 series one. One 170 and 180. Now you can see, do right, ma'am. In DC device, you can go here and just try to run this command. So IP route. Now we are able to see this 161 here. This route is available, and we do have a 150 routes here. And if you will see this route 160 series reachable via 180 1.7.1, and this 150 routes is reachable via 170 1.7.1 till here, right? But guys, this IP, this is 180 1.7.1 is available here on this device, right? So if sometime if there is no routing from here to here, what will happen? It creates a challenge actually, right? It will create a problem. So what we will do, if this route will advertise any route towards here, or if we will receive anything from here and it will advertise here, it will use his interface IP address, because you know in Airtel ISP, if you will go here, so IP route, if you run this command, see we are not able to see anything with regards to the one dot. Now you can see we have this 1.10 series, but it is reachable via 190 1.7.2 190 1.7.2, this IP. sorry, this IP address here, 190.1.7.2 is here on DC router, right? So we have to run this command like next of self command, like neighbor 191.7.2 next of self. Then we have a neighbor 171.7.1 next of self. Then we have 180 next of self. Do right, ma'am. This is the configuration which you need to do on your internet router. Now, if you will go here, type route BGP, you can see all the routes we will be having here. And you can see this time the advertisement, this is reachable via 181.7.1. So it will change in some time, this value. In BGP, sometimes take time to reflect the things. The best way you can run this one, clear BGP all. 65002. Now let's wait here. So we have to just wait here. Now you can see we got the BGP. (181.7.1). Now on this one, they have updated. Here also they have not updated yet. Clear. Do clear or clear BGP all 65002. Because let me just clear the BGP from everywhere. So it will just do the renegotiation again. Everything they will do again. So IP route BGP. So IP BGP. And sometimes you will see all the details. Because BGP takes always some time in the synchronization. Now we have all these routes which we have received 190 series, we have received 110, all that series as well. So run section BGP. Let me just check the BGP configuration on this device. Command is correct here. So IP route BGP. We have the BGP routes here as well. Next up IP, it has not updated yet. So IP interface brief. 190.1.7. Sorry. So 191.7.1, this is the IP address on F0Y1 interface. Now we have this 150 series subnet towards here via 171.7.1. Still we are able to see this interface. We have make the route reflector as well. Let me just go one more time. So run section BGP. They are directly connected as well here. Okay. So if I do the ping to 151.7.1 from here, ping is working. To 161.7.1, ping is working, right? I have the connectivity. Even though from this router, ping to 110.1.6.1, ping is working, and 191.6.1, ping here is also ping is working. So IP BGP, you can see these are the routes in your BGP right now. These are the routes in your BGP, because here we have, it has just maintained the iBGP right now in this segment. Now let me just configure the BGP in my Palo Alto firewall. I'll go here directly into network tab, virtual router. First of all, you have to go into this BGP, enable it, configure the router ID 0.0.0.250, or let me just configure like 10.10.10.250. AS number is 65001. Select this install route option. Reject default route, just deselect this option so it will install the default route as well, which we will see this thing in later in redistribution. Advanced, you can go into peer group and just create your peer group. Give the name BGP peers. eBGP, yes. ISP01 65002. Interface is this. And peer IP address is 151.7.1. Leave everything like that only. Go here. Peer name is ISP2 65002. Interface is this 161.7.1. Let's just leave the things here. Let's go do the OK and just click on commit. Let's wait for this commit to complete. Now we will wait for some time. %99 right now. Let's wait here. Configuration is committed successfully. So IP BGP neighbor. Check the BGP neighbor SIP. It is up with this device in established state, right? And if I go here, if I run this console IP, so routing route type is BGP, and we have received this series route 150, 160, 170, 180, and we have received 190 as well, right? Means these routes we have received successfully. Now, what I have to do now, this till here, everything is fine. Even though I'll go here into this DC router, so IP route BGP, you can see I have the BGP route. If I go here and do the ping to 151.7.250, ping is happening. 160 as well, means I have the connectivity. Now what I want, because on this device I have this route, so IP route, I have this static route, right? Now I want to redistribute this static route into the BGP. So what I will do, I'll go here and I run this command router do so run section router or BGP. Inside this BGP process, I'll run this command default information originate. This is the one thing which I need to run. And what you have to run this command redistribute static. If you have any static route, you can run this command. It will do the redistribution with regards to your static route. Okay, but let's wait here, because by running just this command default information originate show IP route, it will not distribute this route into your BGP. We have to do something extra. So what extra you have to do? You have to run this command as well. Redistribute static. Redistribute static do write mem. Do so run section BGP. So we have to run this command default information originate and redistribute static. If you go here, so IP route, you can just wait here. So IP BGP. You can see it has just redistributed that route as well here, but it's not installed into the BGP, right? Into the BGP table. So what you have to do, you have to go inside this router and you can run this command, neighbor this next hop self. Just wait here in some time. So IP route. Now you can see we have the route and it is reachable via 191.7.2. So this command you have to run next to cell command, because previously it was sending that route with that interface IP, right? So now if you go here, so IP route, you can see, are you able to see the default route or not? We have the default route. Go into your Palo Alto, so IP route, sorry, so routing route type is BGP. So routing route, we don't have any default route here, right? So the thing, you have to go here into your Palo Alto, go here, BGP, reject default route, you have to just deselect that option, allow redistribution. This we will use during the redistribution part. When you will deselect this option and do the commit here, let's wait for this commit to complete. Once this commit will complete, you are able to see that default route here as well. Let's wait here for some time while commit is going on. Meanwhile, if I'll go here and from this router, if I run this console route IP route, you can see I have the default route, which means I can able to ping to 8.8.8.8, which is google.com. Ping is working. 4.2.2.2 means I have the connectivity. I have the connectivity till the internet. Configure the primary DNS server. Not like that. IP domain name. IP domain. Press the question mark. Look up. Source interface is F0Y1. Not this. We don't have anything in the list as well. Okay, just leave this thing. Now let's commit is completed. Go here. Now you can see I have one default route pointing towards 151.7.1. Ping to ping using source, which is 151.7.250 to host google.com. Let's see. See, ping is working, means I have the end-to-end connectivity. Now I got the default route as well from the BGP guy. This is the one. You can go into more runtime stat and you can check your forwarding table as well. We have the default route pointing towards ISP1. Now what we will do now, we will do the redistribution of BGP into OSPF, then OSPF into BGP. So I'll go here, I'll go into this redistribution profile and I'll just create a profile. I'll just create one profile, BGP to OSPF. Priority is, I can give like priority. Let me just give here like 255. Redistribution. I want to do the redistribution. What is the source? Source is BGP. Source is BGP. Click on OK. Create one more profile. OSPF to BGP. Here source is OSPF. Redistribute. Click on OK. Now go to into OSPF here. Deselect this option. Reject default route 1. Export route. Allow redistribution of default route. Type here. Right now I'm inside OSPF, right? So what I will do, what is the source is OSPF to BGP. So I will select here OSPF to BGP. Click on OK. Go to into BGP. Redistribution. Allow default route redistribution. Go here and select here what is the source is BGP to OSPF. Let's do the commit and let's see. And this is the very good article is available from Palo Alto documentation. You can always check this article. Let's wait here. So it has just failed. I think, okay, I think we have used the wrong redistribution profile on both the services. So you can go again, go to into OSPF. Here you have to define the BGP one, BGP to OSPF, and here you have to define the OSPF to BGP. Do the commit. And over the internet, you can get here if you will search how to redistribute, like you can go this route redistribution in Palo Alto. You will get some documentation here as well. How to reduce a static or connected route. Configure route distribution and OSPF. OSPF route redistribution in Palo Alto. You will get these documentation, but you will not get very good documents out there. You can just try to understand the redistribution profile overview and other things. It's 99%. Commit is completed. Now you can go ahead. Go here. Show IP route. We have all the routes. Means your redistribution has been done. See, 190 series, 1110 series, 170, 160, right? 180, 150, and even the default route. If you go here as well, show IP route. So guys, redistribution is a very easy thing. Right now we have did the redistribution. Now you can go ahead and just ping 8.8.8.8. Ping is working with the internet, means we have done the end-to-end routing here, right? Now if you will go into this DC server, so IP route, BGP, you can able to see all your routes. All these routes reachable via 151.7.250 via Palo Alto, right? And if you want to modify this one, right, this interface here, you can go into this one. And if you will do this thing, let me go here first. So IP route, you can see we have the routes here, all the routes reachable via 150 series. Here you will not able to see anything with 160, but because you know 150 series is taking the high precision, but here you will able to see, right? This route is reachable by both the interface, and right now this one is installed in your routing table. I means installed. This one is not installed. Sorry, star this one. This sign means installed actually. Cool. Now you can just try to do one more small thing. You can go here. So run section BGP. Do so run section BGP. Run here. Run. Now try to run this command. Next of self. Towards here as well. Next of self. I think here we don't need it because here it will by default it will apply the next of self only. Because this config we needs towards the IBGP. Do right, ma'am. Conf t do so run section BGP. Next of self. Now you can see now they are advertising with their interfaces only instead of 150. So IP route BGP, now you can check. They are reachable via 170, 107.1. So IP BGP. Here you will see all the BGP routes coming from both the places. So this is guys how we have to do the redistribution, and that's how we have to basically do the BGP to OSPF redistribution, and that's how we have to configure this type of lab if you are having this type of setup in your production environment, right? Let me just go through with the config one more time. It's pretty straightforward. This is the configuration which I did on my internet router, because this is the main router actually. This is the main router actually. Okay, so that's it guys for this lab. Thank you very much.